Okay. Table 7 shows the information of two sets of experiments to investigate one factor that affecting the rate of reaction between zinc and nitric acid. So it's between excess zinc powder, both having using excess zinc powder, and the same volume and concentration of nitric acid. Okay. But the problem is, if you notice, for experiment 2, for set 2, okay, actually added catalyst X. Okay, so normally if you see acid react with metal, normally the catalyst used is copper 2 sulfate. So catalyst X, you can suggest copper 2 sulfate solution. Okay, so here you can see if you got catalyst, okay, in 1 minute, which is 60 seconds, in 1 minute, okay, so for set 2 collected 50 cm cube of gas, but with the same time, set 1 only able to collect 30 cm cube. So that's why, of course, set 2 have higher rate of reaction. Okay, name of the gas. So basically, the equation is the chemical equation is Zn plus HNO3. You will get zinc nitrate and hydrogen gas. Okay, if it is ionic equation, okay, ionic equation is Zn plus H plus, you will get Zn2 plus H2. Okay, so the gas release is hydrogen gas. Calculate the average rate of reaction in set 1 and set 2 in cm cube per second. That's why you have to change to 1 minute to 60 seconds. So same thing, volume over time. Same thing, rate of reaction is volume over time. So basically, 1 is 30 cm cube divided by 60 seconds. The other one, 50 cm cube divided by 60 seconds. So first one you will get 0.50 cm cube per second. The other one you will get 0.83 cm cube per second. Because I keep it as two significant figure, okay? Because here all have basically two significant figure. Compare the rate of reaction between set 1 and set 2. Of course, see, set 2 have higher rate of reaction than set 1. Okay, so reason, let me explain. Okay, so explanation, point number 1, catalysts provide an alternative pathway that can lower the activation energy in set 2. Okay, and then it means provide alternative pathway means shortcut. Okay, give you a shortcut. Okay, later I explain it in the energy profile diagram. Okay, and then what is second point? More covalent particles able to achieve lower activation energy. Third point, frequency of effective collision between zinc atom and hydrogen ion in set 2 is higher than set 1. Straight away jump into F4C7 between the Zn and the H plus. These two particles collide to each other to form hydrogen gas. Okay, you can pause. Okay, draw the energy profile diagram for the reaction between zinc and nitric acid for both sets of the experiment. Okay, then show the activation energy for set 1 and set 2. Okay, so what happened here? Okay, first of all, you have to draw the y-axis energy. X-axis, you can just put reaction pathways. Okay, you can just put reaction pathways. Okay, and then label, that one have no catalyst. Okay, then this one is called EA. EA is called activation energy. The activation energy will be higher. Okay, so and if you got catalyst, okay, it's just like example lah. Okay, let's say this one is from your school. You want to go back to home. Okay, so what happens? This one, if let's say like you got no car, no transportation, literally you have to walk back to home lah. Let's say you walk 5 km. Okay, but okay, if you got catalyst, catalyst is like your savior, your transporter. Okay, anything lah. You call Grab, you take a bus, take a van, I don't know. Okay, as long the van is a catalyst, can bring you faster to get home. So faster means you go the shortcut way lah. Instead of just walking a long way, I can go shortcut. Okay, that's why you call it provide another pathway. We call it alternative pathway. Okay, that's why the activation energy will be lower. This is what the explanation is about. Okay, so and you label. So this one you label EA set 1. So the activation energy is between the reactant and the highest peak of the energy. Okay, because what does it mean by activation energy? Activation energy is like your particle, in order for them to have reaction, itself must have energy first. Must have certain amount of energy for them to start the reaction. Okay, if not, they cannot start the reaction. Okay, so yes, then you label set 2 punya activation energy a bit lower. Okay, but remember, some students forgot to write the reactant. You have to write the reactant here and the product after the activation energy. So you have to draw this. Okay, labeling around 2 marks.